Hi everyone, and welcome back to the channel. Today we're exploring a fascinating topic in computer vision, hand pose estimation. This is the technique that allows a computer to detect your hand, track its movement, and even understand gestures in real time. We're going to break down how it works, and then I'll walk you through a Python script that detects your hand, draws a virtual skeleton, and recognizes gestures like the peace sign, thumbs up, pointing, and more. What is hand pose estimation? Hand pose estimation is a system that predicts the positions of key points on your hand, fingertips, joints, and the wrist. In the model we're using, there are 21 landmarks. Once we know the positions of these landmarks, we can analyze their relationships to understand what gesture the hand is making. This technology is useful for AR and VR, touchless interfaces, sign language translation, robotics, and many more applications. At the top of our script, we import OpenCV, which handles the webcam, image processing, and drawing, and media pipe, which is the machine learning framework that gives us the 21 hand landmarks. Media pipe is an efficient, real-time system built on neural networks. It uses a palm detection model and a landmark regression model to estimate the exact coordinates of each joint. Let's explain the main steps of the code. We initialize the media pipe hand solution. This tells the system we want to track one hand, and sets the confidence thresholds for detection and tracking. We open the webcam using OpenCV and set the resolution to 1280 by 720 so we get more accurate landmark positions. We also create a separate white canvas using NumberPy. This is where we draw a clean 2D version of the detected hand skeleton. It's a great visualization tool because it removes background noise and shows the hand structure clearly. In order to have more stable results, we apply smoothing. This helps to deal with noise. One of the key functions in the script is responsible for determining which fingers are raised. We compare the y-coordinate of each fingertip with the y-coordinate of the lower joint. If the tip is above the joint, the finger is considered raised. The thumb has a special rule, because it moves differently than the other fingers. Here we check the distance from the wrist to determine whether the thumb is extended. After detecting the finger states, we draw the virtual hand. Each joint is drawn as a colored circle. Raised fingers are colored green. The rest remain red, and we draw all the connections to form the skeleton. This gives a smooth and clear representation of the hand. With the finger states, we can now detect gestures. The gesture name appears both on the webcam feed and on the virtual canvas. We can now join all the functions presented together. We can write an infinite while loop that will contain our main script. In order to exit from the live video, then we can press the keyword Q. In order, we will do the following operations. Create a virtual canvas each time where we will show our virtual hand, get landmarks, apply smoothing, detect gesture, and finally draw landmarks and extra informations. Finally, we place the virtual hand into a corner of the webcam feed and draw a border around it so both views are visible at the same time. Let's now run our script. The result is a live system that tracks your hand and displays both your real hand and a virtual version, including gesture recognition. And that's the full breakdown of our hand pose estimation system. You can press Q to exit the screen. If you enjoyed this video or want to build more gesture-based controls, feel free to like the video, subscribe, and let me know what features you want to see next.